All right, question one. You're choosing between two plans at a discount warehouse. Plan A offers an annual membership of $15 and you pay 5%. And Plan B offers an annual membership of $10 and you pay 15% of the manufacturer's uh, list price. So on the first one, express the total yearly amount paid to the warehouse under Plan A, F as a function of the merchandise purchased during year X. Okay. And so what this will be, I've got it's $15 plus 5% of the manufacturer's price. So it'd be F of X would be $15 plus 5%, 0.05 of the list price. Okay. All right. So it'd be 15 plus 0.05x because you have to convert the percentage to a decimal to get the what you want here. Okay. Now B, we want to do the yearly amount for Plan B. So the yearly amount for Plan B, is $10 plus 15%. So it's $10 plus 15%, so it'd be 10 plus 0.15x. So you convert to a decimal there. Okay. Now, how many dollars would you have to purchase in a year to pay the same amount for each plan? So when will it be the same? So we want to know when it's going to be the same. So it's the same when f of x equals g of x. So I'm going to set these equal to each other. So 15 plus 0.05x equals 10 plus 0.15x. Okay, so I'm going to subtract 10, 5, subtract 0.5x, subtract 0.05x, be 0.1x. Okay, divide by 0.1, divide by 0.1, and so 5 divided by 0.1 would be 50. Okay, I'll prove it to you here. So it's 50. So x equals 50. So $50. The total yearly amount paid the warehouse for each plan is, and so what you're going to do is you're going to now plug in 50 into the, is this part D, by the way? Oh, it's so the total amount. I'm going to put total amount to label this. Okay, you want to plug in 50 for X, and you could do it to either one you want in one of the equations. So I'll just do the top one. So f of 50 is equal to 15 plus 0.05 times 50, and that equals, so 15 plus 0.05 times 50, $17.50. Two, football team plays in a large stadium with ticket price of $19. The average attendance has been 50,000. So ticket price of $19. Taking some notes here. Ticket price of $19. I can't see this. The attendance is 50,000. Okay, a market survey indicates that for every $1 increase, so for every $1 increase in ticket prices, attendance decreases by 200. Attendance decreases by 200. Okay. Express the total number of spectators at a football game in as a function of its ticket price. So total number of spectators in as a function of its ticket price. So what's happening here is that you've got to make equations for this scenario. So what's happening is the number of spectators, it's going to be 50,000. Let's define X. X is the ticket price. All right, so what you're going to do here is you're going to take your number of spectators, so your number of spectators is n of x. Okay. So what happens is your spectators start off at 50,000. Okay. But what's happening is that you're losing people. Okay. You're losing people. And so every dollar you increase it, you're losing 200 people. So what I want to do here is I'm going to do 200 times 200 times the ticket price minus 19, the new ticket price. So whatever the new ticket price is, what this is, the difference in the ticket price, how many times you increase it. For every time you increase it, you're going to do 200. So if I increase it 3 times, that new ticket price is 22. So it'd be 3 increases. So 3 increases loses 3 times 200 loses 600 people. So this expression kind of helps you do that. Now let's simplify this. So n of x equals 50,000 minus 200x plus 200 times 19. So 200 times 19, 3,800. So n of x equals 53,800 minus 200x. So 53,800 minus 200x. Okay. Write the function that expresses the revenue as a function of the ticket price. So revenue as a function of the ticket price. So this is the number of spectators. So for the revenue, let me write this on the other sheet here, is your number of spectators, how many people attend, n of x, times number of tickets you sold. Well, the number of tickets you sell is x, or the ticket price. Okay, so the number of tickets you sell, which is spectators, times the new ticket price. Okay, so the revenue will be 53,800 minus 200x times x. Okay, so the revenue becomes 53,800x minus 200x squared. Now, do they ask for anything else? Okay, no, they just asked for the equation there. So it'd be 53,800x minus 200x squared. All right. Let's go to question 3. So in question 3, we have on a certain route carries 900 passengers, each paying $200. Market survey indicates for every $1 decrease in ticket price, the airline will gain 30 passengers. Express the number of passengers per month in as a function of the ticket price. So you've got a 900 passengers, or 9,000 passengers, passengers, and then each pay 200, and then so $1 decrease leads to gaining 30 passengers. 30 passengers. Okay, so now we've got to do the amount per month. It's kind of like the last one a little bit here. So your number that you have, n of x, except for this time you're gaining passengers. So you start with 9,000, but now you're gaining passengers. You're gaining, so I'm going to add, so it'd be 30 times, and then for every decrease in the ticket price. So every decrease in the ticket price. So that would be 200 minus x. Okay, and we could simplify this because I'm decreasing the ticket price here. So 9,000 plus 30 times 200, 30 times 200, 6,000 minus 30x. So n of x is equal to 12,000 minus 30x. 12,000 minus 30x. Oops, sorry. I apologize. 900 plus 9,000 plus 6,000 is 15,000. So I apologize about that. Embarrassing there. Can't do my simple math. Okay. That's 15,000. R of X is the revenue. So the revenue is simply the number of passengers you have times the price that they buy the ticket for. So the revenue will be 15,000 minus 30x times x. So the revenue is going to be 15,000x minus 30x squared. So 15,000x minus 30x squared. I'm not sure if you could leave it in the other forms too. I'm just trying. I did simplify. I don't know if you have to be honest. All right, question number 4. The open box is made from a square piece of cardboard that's 32 inches on the side. So 32 inches each side. Okay, from the corners turning up the sides, use this information to complete parts A through C. So on A, we want to know the volume of the box as a function of the length of the side of the square cut from each corner. Okay, so I've got a box here, which I'm a poor drawing here. So I've got, let's say I have a box, and what I'm doing is I'm cutting from each side. This is very poorly drawn, I apologize. So what I'm going to do is 32 inches each side. Okay, so so I need to do a square. And I'm cutting it from each side. So it's 32 on each side, but then I'm cutting it from each side. So how many sides do I have? So if I cut it from each side, there's 2 sides. So I'm going to be subtracting 2x. Okay, this new dimension is going to be 2x, and then 32 minus 2x here. So I'm cutting 2 because I'm cutting from each side there. So I'm cutting 2 times certain amount from each side. Now also, it's also going. It's going to have a certain height now, and so the height will be x. Okay, and so your volume is equal to length times width times height. So the volume is going to equal to 32 minus 2x times 32 minus 2x times the height, which is x. I think I could leave it like that. I could put 32 minus 2x squared if I want. So 32, do they not like that? Minus 2x times 32 minus 2x times x. Let's see if it likes that. Oh, it did like that. Okay, good. We're going to leave that alone then. Find B of 3, B of 4, B of 5, B of 6, and B of 7. What's happened to the volume as I cut, as it increases? So for B of 3, I'm going to plug this in. 32 minus 2 times 3 times 32. Or I should just do this. I'm going to rewrite this as a squared. So I'm going to rewrite this as squared. So B of x is equal to 32 minus 2x squared times x. I'm just going to write, this is going to make this easier. So B of 3, I'm going to do 32 minus 2 times 3 squared times 3. Okay, so 32 minus 2 times 3 squared. So it'll be 676. Okay. There's a lot of parts to this. And the side of the square cut from each corner of the piece. Okay, there you go. Whoops, sorry about that. Is when the side cut, that square cut from each corner of this in the center of the edge. Okay, I apologize. I forgot to multiply by 3 here. So it's 2028. I forgot to multiply by 3. So it's 2028. So if I cut the corner from 3 inches, B of 3 is 20 when it's cut the corner of 3. So now we have to find and interpret B of 4. So B of 4 is, and we'll go back to the equation here. Back to our equation. So it's going to be 32 minus 2 times 4 squared times 4. And another way you could do this is you could enter this into your calculator, go to y equals, enter this function in there, 32 minus 2x squared times x, and go to second graph. And so then you could see like V of 3 was 2028, V of 4 was 2,304. So that's a quicker way to do that. So 2,304. And so that would be your value for there. Interpret V of 5. So 5, that's when x equals 5. So it'd be 32 minus 2 times 5 squared times 5. Okay, and you could type that in your calculator. I could also go to the table I just made earlier, so 2,420. So 2,420. Oh, we got to be careful there. They split from each corner. They switched it on me. Square from each corner of the piece. So V of 6. So now I'm going to do 6. I'm going to write this down here, so I'm going to have some room. So V of 6 is equal to 32 minus 2 times 6 squared times 6. And so I can just go to 6. That'd be 2,400. Okay. So that's when it's square cut from each corner of the piece. This would be 2,400. Whoops. So now V of 7. So now we're going to plug in 7 into the equation. So we plug in 7, and we get 32 minus 2 times 7, so it'd be 2,268. Now we start to see a decline here. So the volume would be when the square cut from each corner. Okay, so that'd be 2,268. As I said, starting to see a decline. So what's going on here? So what's going on? It looks like the volume, it's getting greater, and you can see from here in the calculator, it's increasing, and then it peaks up at 5, and then it starts decreasing. So we get a maximum at 5, and then it starts to decrease. So the volume reaches a maximum at 5. Okay. Let's find the domain of V. So for the domain of V, well, V, we look at the x values, okay? And so we're looking at this, the side is 32. So 32 minus 2x squared times x. So now we want to see when is the point, and we could look at the graph here. What are the possible values of x? And so we basically want to find this 0 here. Okay, so we'll see it at 16. We want to find the 0 here, and so the zeros. And so to find the zeros, you could set this equal to 0, and then we have x equals 0, which is one of the zeros, and 32 minus 2x equals 0. And this becomes negative 2x equals negative 32, which becomes x equals 16. So it'll be from 0 to 16. Now, it wouldn't include, or actually the volume, I guess it could include that, but technically it wouldn't have that. So in this case, it'll be from 0 to 16. So from 0 to 16. All right, let's go to question 5. You have 450 feet of fencing. Okay, and you have a rectangular field. To enclose rectangular field, express the area as a function of one of its dimensions. Okay, So you have 400 feet of fencing. So what that means is area is length times width. Now, are they going to use this in terms of X? I need to know the letters they're using here. Oh, one of the dimensions X. Okay. So one of the dimensions X. All right. So we have this rectangular field, and so but this 450 feet of fencing gives you the perimeter. Okay. And so the perimeter is 2L plus 2W, and so 450 is equal to 2L plus 2W. Okay. And so on this one, what we're going to have to do is we're going to have to solve for one of these variables because we have two. So let me solve for the width here. I'm going to solve for the width. So to solve for the width, I'm going to subtract 2L, 2W equals 450 minus 2L, divide by 2, W equals 225 minus L. Okay. Now what I'm going to do next is W equals this. So I'm going to plug this in for W up here. So the area equals the length, which is L, times the width, which is 225 minus L. Okay, so then I'm going to multiply 225L minus L squared. And so that would be the area. Now, I'm going to use this in terms of X. I'm going to change L to X. It'll be 225X minus X squared. 225X minus X squared. All right, question 6. You have 400 feet of fencing to enclose a rectangular field. However, the field is along a canal and requires no fencing. Express the area of the field as a function of its length. So you have 400 feet of field, or feet of fencing. Okay, however, the width the field lies on a canal. Width requires no fencing. Okay. Express the area of a field as a function of its length. So I've got a rectangular field. This is gonna, and so you got a canal, and so you're gonna have a length, and a width. So your 400 feet this time, your perimeter that you're going to cover here is going to be 2L plus W. That's going to be your perimeter of this thing. So 400 equals 2L plus W. Okay, and we want to do the area of the field as a function of its length. So length is X. So I'm going to subtract 2L, kind of the same thing. W equals 400 minus 2L. And area is, remember, area is length times width. So we need to change L to X and substitute. So we need to change L to X and substitute. So it would be, so I'm going to substitute this into here. So the area of X is equal to the length, which is X, times the width, which is 400 minus 2X. I don't know if you need to distribute or not. 400X minus 2X squared. So 400X minus 2X squared. Seven, let P be a point on X squared minus 10. So let P Y be a point on Y equals X squared minus 10. Express D, the distance D from P to the origin as a function of its coordinate. All right, so the first thing I want to do is I'm going to use the distance formula. I'm going to let 0, 0 be x1, y1. And I'm going to use the distance formula. It's a square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance is going to be the square root of x2 minus 0 squared plus y2 minus 0 squared. So distance is going to be the square root of x squared plus y squared. Now what I'm going to need to do now is I'm going to need to plug in x squared minus 10 for y. So distance is going to equal the square root of x squared plus x squared minus 10 squared. Okay, and I've got to figure out what x squared minus 10 squared is. So it'd be x squared minus 10, x squared minus 10. So that'd be x to the fourth minus 10x squared minus, oops, I'm trying to cram this in here. X to the fourth minus 10x squared minus 10x squared plus 100. So it'd be x to the fourth minus 20x squared plus 100. So the distance is going to equal the square root of x squared plus x to the fourth minus 20x squared plus 100. So the distance is going to be the square root of x to the fourth minus 19x squared plus 100. So there's your distance. Okay. And so this would be our solution, the square root of x to the fourth minus 19x squared plus 100. All right. Hey, we've got a track here. Oh gosh, can I fit this in here? Be very close here. So I've got a track. New running track is considered the shape of a rectangle with the semicircles on each end, as shown in the figure right. The track is to be 470 yards long. So it's 470 yards long. Based on the innermost lane, express the area of the region enclosed by the track as a function of its radius. So the area of the track as a function of its radius. So we know that the area of the track is going to be, we're going to have a kind of a composite area here, and I'm going to draw this out on the paper. All right, sorry to draw this out real quick. So it's the area, it's two semicircles, so it'd be 1/2 pi r squared plus 1/2 pi r squared plus the area of the rectangle, which would be, it looks like it's going to be x times 2r. And so why is it 2r? It's because this side, the entire length is 2 radiuses, okay? So now what I need to do is, and they want you to factor completely and type an exact answer. Okay. And the whole thing is 470 yards long. So 470, and that would be the area of the track is 470 yards long. So the perimeter would be 2 pi r, be pi r plus pi r, which would be 2 pi r plus 2x plus, and that would be 4r because you have each side is 2r. So the perimeter is 470. So the 470 is equal to 2 pi r plus 4r plus 2x. And I've got to solve this for x. So I'm going to subtract 2 pi r, subtract 4r. So that, and then, so 470 minus 2 pi r minus 4r is equal to 2x divided by 2 divided by 2. X is equal to 470 divided by 2. So 470 divided by 2, 235 minus pi minus 2r. And so now I'm going to plug this into this original equation here. trying to make some more room. And so as I do that, I'm going to have A equals 1 pi r squared. That'd be pi r squared, okay, plus x times 2r. So x is 235. Minus pi minus 2r times 2r. So the area is going to equal pi r squared plus 235. To actually be double that, to be 470. 470r minus 2 pi r minus 4r squared. Okay.